Welcome back, guys. Today we are going to solve LeetCode problem 404, sum of left leaves. Before we start looking this problem, I just want to mention that I often create LeetCode solution videos in Java technology, and I also create Java J2E interview related helpful videos. So please check out my playlist. It has a good amount of stuff in it, like it has LeetCode solutions, BFS, DFS, dynamic programming, and linked list related videos. Also, it has videos for Java J2E interview questions and answers. So please check it out, and please subscribe to my channel now. The subscription is really helpful. So let's look into the problem. So given the root of a binary tree, return the sum of all left leaves. So this is the binary tree that is given to us, and we have to return the sum of the left leaves, right? So let's take this example over here. So we are going to solve this problem using recursion. So what we are going to do is we are going to traverse the binary tree from top to bottom. From root we will start, and every node we visit we will ask the question whether it has any left node which is a leaf, right? Which is a leaf. So leaf node is a node that does not have any left and right children. So we will ask, now we are at 3, which is the root, right? So we are going to go left and go right. So when we are going left, we will ask first, when we are visiting 3, we will ask, do you have any left leaf, right? Left leaf. So it will check if 9 is the left leaf it has. So 3 will say that I have a left leaf 9, so it will give us the sum is equal to sum plus 9. So our sum becomes 9, right? So then we will visit 9. Now again we will ask, do you have any left leaf here? So there is no left leaf, right? Null. So nothing will happen. So sum will be 0 in case of null, right? So we will, our sum is still 9. So now we will go and we will visit 20. So 20, when we are visiting, we will ask again the root 20, do you have any left leaf? So it will check if it has any left leaf. So yes, it has a left leaf 15, right? So it will add 15 to our sum. So it will become 9 plus 15, which is equal to 24, right? So 24. Now when we are visiting 15, do you have any left leaf? No, right? It is null, so it doesn't have any left leaf. When we are visiting 7 also, do you have any left leaf? No, there is no left leaf, right? Null. So we are done. We have visited all the nodes of the tree. So we will return our sum as 24, right? So that's what you will see here, the 24 is coming. So that is the implementation using recursion. So I am going to show you the recursive function that I implemented. So first thing I will show you is I implemented a helper function here called as isLeaf. So it takes the tree node and it checks if it is a leaf or not, right? It just checks if it is leaf. So it checks its left is null and right is null, and it itself is not null, right? Then it is true, it will return true, otherwise it will return false. So it checks if the node is leaf. So now we will call the recursive function from the main function, and we will just pass a root here. In the recursive function we have defined a sum variable 0, and whenever node is equal to null, right, then which means that when it is checking if it is left leaf, it will when it finds it's null, then we will just add a 0 to sum, right, because there is no any left leaf there. So we will just add 0 and we will return a sum from this function. Okay, and otherwise it for every node that we are visiting, we will check if is leaf, right? We will, and is leaf, we will pass its left child here. See, we are passing the left child here, and we are checking if its left child is there and it is a leaf. If it is the case, then we will add that node's left value into the sum, right? For example, if we are at 3, node 3, we will add 9 value here into the sum, right? So that's what we are doing. I just have this println to show you that the sum, how it prints the sum actually. I will just show you and then we will take it out. and then after we are done with the isLift check, then we will just recursively call the function, because once we visit 3, we want to visit the left subtree and the right subtree. So that's what we are doing. We are calling the recursively. We are passing a left node here and we are passing a right node here, because we want to visit the left subtree of the node that we are visiting and the right subtree of the node, right? So that's what we are doing, and finally we will get the sum out of it and we'll just return the sum. So that is the approach, and these are the test cases that are given to us here. So let's just quickly run and make sure it's working fine. So as you see here, so sum is 9 first, and 9 plus 15 it will add and it becomes 24, right? So that's how we are getting the correct result here. So we will just remove the sum or just comment it out, and we'll just submit and make sure the submission is working. So our solution is 100% faster and it's 0 ms, and on the memory also it is 94%, so it's pretty good. So this is a solution that we have for sum of left leaves. So it is just recursion. So it's just question, if you understand the recursion of the binary trees, you can easily solve this problem. I'm going to add this solution into my GitHub repository, and I'll give you the link in the description. Check it out. I already have placed a lot of code in my GitHub repository about LeetCode solutions and other things, so check it out there. Also please subscribe to the channel. It's helpful if you subscribe to the channel, so it can reach to more people. Thanks for watching this video.